All right, welcome to Mobi Publishers, and this is number 18. So number 18, we are required to complete the table below for the function y is equals to 7 plus 2x minus 2x squared for the range -3 is less than x is less than or equal to 4. So in doing that, not all the values have not been calculated, so a few of them have not been calculated. For example, this one here, so this is -2 into -3 squared, it gives us -18. Just insert, and if we want to get to y, we simply add 7 plus -6 plus -18, and we get -17. Similarly, you can check the values in this column. And then this one is 2 into -1, you get -2. And then this one also is the sum, 7 plus -2 plus -2, it should give you 3. Then similarly on this column, and so on. So the values have been given here. You can take your calculator and check that in this case you have -2, that is -2 into 1 squared, it should give you -2, and 2 into 1, it should also give you 2. The sum again, 7 plus 2 plus -2 should be able to give you 7. The same thing applies to the value x is equals to 2 and y is given as 3. Check that one also for 3, and then confirm that -2 into 4 squared gives you -32, and 2 into 4 gives you 8, and the sum 7 plus 8 plus -32 will give you -17. Then now we are supposed to draw. So you are told on the grid provided, draw the graph of y is equals to 7 plus 2x minus 2x squared. So we simply plot, and I think here something to note is choosing the scale. All right, so you look at the minimum value of x and the maximum value of x. In this case, the minimum value is -3 for x, and the maximum value is 4. Sorry, it is 4. So that's why down here we have 2 centimeters representing 1 unit, because we have enough space up to 4, that is on x-axis. But when it comes to y, the range is different. Is the lowest is -17 and the highest value is 7. So 7 plus 17, it gives you 24. So we need 24 boxes. We need 24 boxes. So when you check here, that is the reason why our scale is given as 1 centimeter representing 2 units, because we did not have enough of boxes to be able to accommodate 24. So plotting here is not a big problem, because you just check the x and y, right? For example, we take -3. -3 here goes with the -17, right? And so on. So you can check this coordinate, you can check that coordinate with what we have on the table, that is -2, -5. You can check that coordinate, right? So -2, -5, and so on. So it gives you a curve. But there is something I want us to note, look at this point here, 7 and 7, that is on y. So we have to take a value in between here so that we don't get confused. So we have the 7 here, right? We have the 7 here, and we also have the 7 here. So in between is 0.5, so we must check the maximum point or the turning point before we mess up with the turning. And so I check 0.5. So 0.5 as the value of x inserted on y is equals to 7 plus 2x minus 2x squared. It gives us a value of y as 7.5, and it happens to be the highest value of y. So having that will assist us to draw a very smooth turning point along this point. So you can quickly check if there is any other point higher than that for your own convenience. So that is the graph, that is the graphical representation. So you can see we also have a line here, but this is meant for the next part of this question. This is meant for the next part of this question. And the next part of this question, as we have seen, we have used our graph to estimate the roots. So, and the roots, if we go back here to the graph, is where the curve intersects with the equation y is equals to 0, and that is the x-axis. So this is the point of intersection here. That is the point of intersection for that curve. Then you are told, by drawing a suitable line on the same axis in B above, solve the equation. That is 9 plus 5x minus 2x squared is equals to 0. So what we do is we put these equations the way I have put them here, side by side, and get the difference. So having y is equals to 7 plus 2x minus 2x squared is 1. Then you subtract the equation 0 equals 9 plus 5x minus 2x squared, and that one leaves us with y is equals to negative 2 plus negative 3x plus 0. We only need 3 points on the extreme to be able to get our straight line. So one of the coordinates is negative 3, which gives us 7, and the other one is 0, and which gives us the value of y as negative 2, and the other one is 4, which has a value of negative 14 as y. So from this graph again, because we use the same graph, you can see our equation plotted. So the extreme end here we have negative 3, 7, and then at this point here we have 0, negative 2, and at this point here, right, we have 4, negative 14. So those are the extremes, so that we can have the line crossing through the curve, right, like that. And therefore the points of intersection here will give us the solution. So in this case I have produced them here, so you should be able to use your scale here and get that is negative 1, okay, negative 1.5, and in this case this is negative 3 point slightly more than 5, that is 0.7 3.7. So those are our solutions. So we have the coordinates here. For x, the value is negative 1.3 approximately, and the other value of x is 3.7. So but the coordinates of the turning point, we calculated it earlier as 0.57.5. Thank you very much for watching. If you like it, you can subscribe so that any other time we have material like this, you will be easily notified. Bye bye.